All right, welcome to Auth Part 1 of 3. So let's talk about the shape of this series a little bit. So there's 3 parts to this. Today we're going to learn about creating users. Tomorrow we're going to authenticate users. It's like logging in. And then in the last part, we're going to make it so that there's some things you can do when you're logged in and other things that you can't do unless you're logged in. So for today, by the end of today, you should be able to create new users in Rails. And I hope that each and every one of you will be able to explain how hashing works. Now, it might have been a second since you looked at Rails. So let's refresh ourselves. HTTP request comes into a router. Router matches a method and a path with an action on a controller. Sends it to that action on the appropriate controller. We can interact with models, which interact with the database for us. We get our shit back to the action. We render out a response. Questions so far? We all remember Rails? So what we're going to do is make new users. 80% of this is exactly the same as creating any other model. There's a very slight difference we'll do for handling passwords, but it starts off the same as anything else. So what we're going to do is I'm going to show you what this looks like end to end. Then we're going to do it together as a class, and then you're going to do it on your own. And then we'll talk about it. Okay, so for this first part, just watch. These are the steps that I'm going to follow. I'm going to install a gem. I'm going to make a route to create a user. I'm going to make a controller and an action to create a user. And I'm going to make a user model with a secure password. Mira. So I'll call this Auth November. So I make a new Rails app. Oops, I didn't do an API. Come on, Kyle. Who raised me? Me? Rails new -- API. I was like, why is it installing a Sass plugin? Oh, yeah. There we go. It's more like what I was expecting. All right, so I go over here. Step 0, install B Crypt. So I'm going to bundle install B Crypt, or bundle add B Crypt. Cool. Oh, actually, so I put it right there. Also, you can just uncomment it out. It's in your gem file already. So you can do it that way too. Either way, doesn't matter. All right, so I've installed B Crypt. Now I want to create a route to create a user. So I go to the router. I say, if somebody makes a post request to users, send that to the users controllers create method. I could also do that as resource users only create. Either way, same thing. Done. Now I'm going to create a controller that creates a user. So I Rails G controller users. Go into that controller that I just made. I'm going to make a create method. This, just like it was with every other Rails model you've done. I'm going to say that a user is user.create. Username, well, how about whatever username they sent us? Password, well, how about whatever password they sent us? We could also put anything else we want on there. Real name, age, favorite puppy, like any of that stuff. Doesn't have to only be these things. And then I'm going to render JSON like that. Done. So I've created a controller to create a user. Lastly, I need to create a user model with a secure password. This is the only part that's a little different. So I'm going to Rails G model user. I'm going to go into that user model, and this is a macro. This is like a adder reader, adder writer, adder accessor, any of those kinds of things. Similar kind of thing. This is has secure password. That's it. Now we're going to go to our migration and say that we have a string called username and a string called, wait for it, slightly different, password underscore digest. We'll talk about what the digest part is in a sec. Cool. That's it. That's all of step one. If I migrate that database and fire up Postman, I should be able to create a user. All right, so I'm running on 3,000. I make a post request. Username Kyle. Password Kyle. What do you know? I got a new user with a digested password. That's it. That's all we're doing in step one. Ask me some questions about it.
So I know that if we, why do we create the controller and the models and stuff? I know that Rails G resource will give you views also.
Yep.
But why wouldn't we just use the resource?
You can. It also gives you a bunch of other shit that, like, you either have to delete or change or whatever. So I like doing them separately, but you don't have to. Doesn't make a difference.
Okay.
You've got password digest in the schema, but only password when you're posting it.
Yeah, so that's the big one. When we send it in, it's password. In the controller, it's password. In the database, it's password digest. The model turns the password into the password digest.
Is that because that has secure password?
Yes, that's what has secure password does. So let's talk about why. This is the how hashing works part of this. So let's say I got a database of passwords so that I can make sure that when somebody logs in, I can check their password. Kind of makes sense. So I'm logging in with Kyle, and goes into my app, goes into my database, goes, is the password Kyle? And it goes yes or no, and then does something in response. So this is how you sort of intuitively think that this works. What's the problem with that? Why is this is dangerous? Why?
Kyle's not unique.
That's part of it.
Like Kyle is, I guess, when the hashing occurs and it kind of changes it into symbols. If somebody were to access your database and able to see that it's just Kyle, like then you could have like a data compromise.
Oh yeah, man. If somebody can break into this database, if somebody steals this database, they have everybody's passwords. People reuse those passwords in other places. Well, now you have those too. You can impersonate them on the app.
So I have a question for you, Kyle. Like, when you start to think of some of these very sophisticated apps that have had like massive data compromises, are they not using this technology or something to protect the passwords? Or
a lot of them are not.
Wow.
So, and like, to be clear, it's not different at scale. It's that one line. And even like outside of Rails, like it's easiest in Rails, but I'll show you the one for the Firebase app. It is, so it's the exact same thing in Node. There we go, 40 lines of code. And that's like doing everything by hand. Ta-da. Now, a lot of those database breaches are not of plain text passwords. A lot of them are of hash passwords, which there's like some danger in that also, but like substantially less. But let's talk about what hashing is and why that helps make things more safe. I'm going to show you that by way of Kyle's shitty hashing algorithm. Works like this. You do letter number substitution, and you add everything up until you get one digit. That's my shitty hashing algorithm. So if I have cat and I run it through Kyle's shitty hashing algorithm, then we do C is 3, A is 1, T is 20. Okay, so I add those together and I get 23. I'm trying to get down to one digit, so I add those together and I get 5. So once I've run cat through Kyle's shitty hashing algorithm, it hashes to 5. Now, here's the important thing you have to understand about hashing. As you can probably tell, there's other ways that you can get 5 also. If it was E, that would also hash to 5. If it was A 5 times, that would also hash to 5. Hashes are not unique. In an actual hashing algorithm, like B Crypt, what we're relying on is it's so complex that your ability to intentionally generate something else with the same hash is statistically impossible. That's what all of our security is based on. Statistical and improbability.
So that giant key that it returns is essentially doing something similar to this.
Exactly. So I put in Kyle and it hashed to this. So how do I use that to log into my app? If I'm not storing a plain text password, how do I know that the password they gave me is the same one that they entered before?
The first thing I'm inclined to say is like that the hash is gonna kind of line up with your plain text password, but as you just mentioned, there's a bunch of different ways that you could arrive at that. So that kind of begs the question, how does it know that that version of the hash equates to Kyle instead of A 5 times?
Right.
Don't know the answer.
Anyone got any guesses? If I have Kyle and I have the hash of Kyle, how do I know that they match?
Does it so if it's stored in the database, does it compare the next time you put it in?
You're right there. Compares what? I've stored the hash password. I have this in my database. When somebody logs in, they're giving me their regular password. How do I tell that these two things go together?
Compares the new key that's coming in with what's in the database, what's cached.
So I've got this in the database. I can't compare it with Kyle.
The new
What
key
should I compare it with?
into though.
Can you like apply the hash again?
Ding, 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 ding. I can hash this again and see if it's the same thing. I can't reverse this hash and get back to Kyle in the same way that I can't reverse 5 and get back to Cat, because it could be the letter A 5 times. It could be any number. It could be E. It could be any number of different things. So there's no way to reverse this back into what it originally was. So it's safe to keep that in a database. Somebody steals your hashed passwords. They don't have nothing, but they don't have much. There's just not much you can do with a hashed password. So if somebody gives me their sensitive password and I hash that, I can compare that because it's always going to be the same value. The hashing algorithm produces the same thing every time. And that's how you can figure out if somebody is who they say they are. So this comes into the app. And if I hash Kyle, and look up the stored hash, are they the same thing? By the way, hash is a cryptography term. It's also a breakfast term. They're referring to hash browns. When you make hash browns, you scrape up some potatoes, put them on a grill, flip them around. For too long, you can't tell which potato, which part of the hash brown came from anymore. That's hashing. Ask me some questions about it.
I mean, if you were doing like a targeted thing, I don't know. Let me think of somebody. Let's say I was trying to get into like Donald Trump's Twitter or something,
Okay.
right? I feel like Twitter's been like compromised before. If I was able to get his hashed password, I mean, realistically, it's not really gonna take me that long to figure out what it is it? I mean, there's a finite amount of possibilities that are gonna equate to well, that assumes I know what the hashing algorithm is too.
It does, but you get a reasonable chance at guessing that. In fact, it's stored like in this. The first part of this is that this is using version 2A of the B Crypt hashing algorithm at a cost of 12. So you actually have that embedded right in the hash. But if you have somebody's password hash, what you need to be able to do is you need to be able to come up with a string that generates that hash. That's monumentally hard to do because it's not going to be Kyle generates that and Kyler also generates that. It's going to be Kyle generates that and then this other fucking 5,000 long string also generates that of completely random characters and something else that's completely random. Part of the point of hashing algorithms is that a small change in the input results in a huge change in the output. So, okay, so this is the hash for Kyle. Check out what it is for Kyler. Oops, I'm not running the server anymore. Okay,
great,
what is it
great
with,
bit different.
what is it with Kylet? Not even close.
All right.
Now, that doesn't mean there's nothing you can do with it. You can have a computer that's just doing random strings and trying to generate that hash. That's called a rainbow attack. There's a protection against that too, and it's called salting. We'll probably talk about that more tomorrow. But
Is this like how Anonymous breaks into people's stuff though? Like they grab the password hash and they have sophisticated enough tools to figure out what, how to get into their stuff and mess with it, or?
no, I mean, like in the case of Donald Trump's Twitter getting hacked, they guessed his password.
Okay, gotcha.
It was mega 2020 exclamation point.
Okay.
So like a lot of those things are more like that. Or another way that, actually, this is the way that most hacks happen, is the best tool in a hacker's arsenal is like a maintenance uniform. You just walk into a building, look, and like having worked in stage production before, if you walk around a building in a uniform looking like you belong there, nobody even talks to you. They just assume that like, all right, well, somebody must have scheduled you for something. And once you have physical access to a place, woof. That doesn't happen so much with like Twitter and Facebook and those kinds of things, what happens with them is you get on the phone and start crying and go, I can't get it. It has my baby pictures. And I can't, I feel like I'm going to lose everything. That's like, and that was a go-to for Apple for a while. If you cried hard enough to Apple, they'd let you into anything.
Wow. Okay.
Yeah. So that's called social engineering. 95% of hacks are social engineering. Or if you can figure out somebody's like high school mascot and the street they grew up on, their mother's maiden name. Like none of that shit is especially hard to find. If you can do that, you can get a password reset. You can lock somebody else out of their account. Cool. All right, so other questions about hashing.
With like a lot of websites have required, you have to use a capital and special characters and all that.
Yep.
Is that just doing the same thing like hashing but more challenging? Like or is that different?
That shit's security theater. It really doesn't do very much. So what it does do is it makes it harder to guess. Because if it's just a bunch of lowercase like English words, all right, well, there's a very finite amount of those. So you could just run a script that goes through the entire dictionary, tries all those words, tries different combinations of those words. So like that's not super secure. If you add extra characters to it, it makes it substantially harder. It's like, okay, well now I'd need to do that with all the lowercase letters, all the uppercase letters, every combination of those, every combination of all of the combinations of those with numbers, all the combinations of all the combinations of those with all the symbols that you allow. Like, so it just makes it harder to guess. But you could also just make your password longer. Like this, so you might have heard the term SKCD password before. If you haven't, there's a comic that explains all of this very succinctly. Take a second to read it. So the TLDR on this is you could use a bunch of goofy fucking symbols, or you could just make your password a little bit longer. It's way more successful at that. Cool. Other questions about hashing? Cool. All right. Let's get back to our steps. So I said that I was going to do it, we're going to do it, and then you're going to do it. So it's time for us to do it together. And we're going to do this whip around style. So how that works is that we're each going to take turns doing one step. So I'll do the first step. I'll make a new Rails app. All right, William, give me the next step. Unmute.
The next step would be, let's see, we did the Rails new, so now we need to create a path now, right?
We could. That works.
Do the path now.
Yeah, sure. So if I go over to the router, what do I put in here, William?
You're going to put. I guess we could do it the first way that you did it. You could say like, so a post request to users go, and that's right. It'll go to users hashtag create two colon open parentheses users / create.
No, this is it. You got it.
Okay.
Okay, very nice. Jason, give me another step.
We need to B Crypt gem.
Ah, shit. Yeah.
So what do I do?
You can uncomment it on line 16 there, or if it's not in there, you can add it.
Beautiful. And then do what?
And we'll install.
Yes. Okay, very nice. Rodney, give me another step.
We can. Do we create the or add into the migrations?
Yeah, we do that now. So how do I do that?
You have to create the migration Rails G migrate
Whoop.
migration.
It comes with something else. We get the migration when we generate a new
Controller
almost.
model.
Yeah. What's the model called?
Users.
User singular.
User.
Controllers are plural, models are singular. Why? I don't know. Just memorize it. But controllers are plural, models are singular. Okay, very nice. Katie, give me another step.
We need to go into the migration, right, and add whatever, like, what do we want in there?
Username and password.
Sorry, I'm like looking for my old notes, but they're so far down, I don't know where they are.
So what's the data type for both of these?
String, right?
Yeah. And then what do we pass into the string method?
The user?
Username.
Yeah.
Just the name, whatever you want the column to be called.
Right.
Okay, but now this is the tricky part though. The password was actually what?
Sorry, I don't remember.
Password, somebody help Katie out.
Underscore digest.
Underscore.
Oh, right. Thanks.
There we go. Cool. Back around. William, what am I doing next? Unmute.
We got the password digest. Have we done on the user model? Have we done has secure password yet? Have we done that yet?
No.
Okay, so yeah, let's do that.
Okay, very nice. Jason, give me another step.
So I think on our controller, we just need to do the create method.
Controller? What controller?
User control. Oh, we haven't made it yet. Sorry. Rails G user controller.
And then what's the controller called?
Users.
There we go. plural controllers, singular models. All right, so I go into this controller, and what do I put in here?
Def create.
Cool. All right, switching over to Rodney. What goes inside of the create method?
We're gonna have at user equals user.create,
Yes.
parentheses, open it up with username, params, and then inside an array with a symbol username,
Good.
and the same thing for password.
Good. Okay. Katie,
Oh.
what's next?
Uh, oh, sorry, I muted myself. The render.
Yeah.
Thanks. Like render JSON, like
Good.
user.
Yeah. Okay, very nice. So if I'm looking at my notes, got that, we got that, we got that, we got that. There's one last thing. This one's a free grab. One last thing we got to do before this is going to work.
Did we migrate?
We didn't migrate. All right. So now if I run this server, run it on 3000, I make a post request to 3000/users. I send some JSON over with my name and my password. Pew, pew, pew. There's user one. Questions about that process?
Hey Kyle, in your users controller, when you render, can you just put render JSON with the symbol and then at user? Or do you have to put it inside a hash like that?
I would highly recommend putting it inside of a hash. And the reason why is because you may want to return other things along with this response. So it could be some other model that you want to bring back also. It could be an error message. It could be a warning. It could be a status. There's all kinds of things that you might want to bring back as part of that data. And so I will just about always wrap it in a hash and a key. But no, this will also work if you do that.
Okay, so we would use so like if we have multiple things that we wanted to pass in there, that's when we would. Gotcha.
Yeah.
Cool.
Other questions?
Oh, what was the other way to type out the path in our routes? You said that we could do like resources.
That's the same thing.
Okay.
And then like as we make, so the difference between them is that, all right, now I want to be able to list my users. And so I do that. All right, well, I want to be able to get a single user. So then I do that. Or I could do, and just keep adding them to that. And then eventually when I have all of them, then it's just that.
Okay.
Other questions?
I guess it's more of looking towards what really happens in part 2. So I guess all we've really done at this point is have the ability to create a user, and with the with secure hash, with secure password and password digest, now we've created like a secure password. I guess the next step is like matching that.
Yes.
Right.
That is
Okay.
exactly what part 2 is.
Okay.
Mapping stuff. this process of hashing the password they gave us, comparing it to the one that we've stored. That's step 2. Other questions about any of this? All right, time for you to put it into action. So I would like everybody to start with 5 minutes. 5 minutes, see if you can go through all of these steps on your own. And go. right. Let's do a quick check-in. Give me a fist to 5. Fist is, I don't know what we're supposed to be doing. 5 is, I got shit coming back. I got a hash password. All right. And then Katie, how you doing?
I got it working.
Cool. All right. So, William, why don't you go ahead and screen share it, and let's see if we can debug what you got going on.
Unmute. Okay. I just hadn't finished yet. Where it took me a minute to realize like I had to be inside the folder to get B Crypt installed. So
Also, let's touch up your routes a little bit. So
okay.
you got the start of this right. This is unusual, but users and create your controller and your action. That's inside of a string, the whole thing. So it
Oh,
should
the whole
two-
thing.
Yeah.
The 2 is also inside the string?
So,
Okay.
so ultimately, like 2 is a key and a hash, and the value of it is this string. And so it's going to
Okay.
be users hash create. Yeah.
Gotcha.
Like that.
Okay. I was making the controller here. Boom. Okay. There we go. Cool. And then I guess I go ahead and make the model as well. Okay. I don't know which one first. I guess we can go into this one first, right? And so the controller has the create method on it. It's gonna say at user equals user dot new.
Do create.
Oh, user, yeah, user dot create, correct, yeah, because it makes it and saves it, right? Do I need to do?
You got an errant E at the end of line 1.
Errant E at the end of. I see it. I don't. Do I need to?
I'd recommend it. If this is going to make this part easier to read.
Okay. Okay.
Open that up.
Right. And am I putting the username and password like parameters in here?
Yep. It's
Okay.
so ultimately you're passing in a hash.
And oh, a hat. Okay. So, user or no, that doesn't need to be a string, does it?
Correct. Shouldn't be.
Right. Username, and it's also gonna have here. It's called password.
Correct.
Okay.
You're gonna. This is just like JavaScript. You're gonna set those two params username and params.
Yes. Well, then I'm probably gonna take that down onto next line equals.
Not equals, just like JavaScript. It's a colon.
Yes. Params. Username.
Yep.
Right, and then comma. Here we go. Password. Params. Password. Okay, that should be okay.
Yep.
No trailing comma. All right, now we got to go to our model.
Let's finish this one up.
Okay. Oh, yeah, that's right. We gotta render JSON. And then we're gonna go user at user.
You got it. Now
Okay.
also, you want to close off this method that you're in. So that end is for the class, line 9.
Oh, and yeah, that needs to go up. Okay, yeah. option. Right.
Literally the word end.
And the word end should be inside it as well. All right. Oh well, no, derp. I got you. I get what you're saying. Yeah.
Cool, very nice. All right, and then let's take a look at the syntax on this.
Oh,
So,
I need here for sure.
so that closing curly you have on 7, that should be before the render.
I did have it in the right place. Okay.
Yep. And then I would also put a closing parentheses and opening one before your hash starts.
Okay.
Yeah, and there. Cool. Bring line 7 back an indent. All right. I've never seen a finer controller in my life. All right, keep going.
Okay, save that. All we really need to do here, I think, is this has secure password. Okay. And then I need to go into where's it at? I know what I'm looking for. Where is it? Here. Right. Okay. And here we're going, let's see, it has password, so, yeah,
You're on the right track, man.
Yep.
Trust yourself.
right,
So that's what you're going to call the column. The T dot is going to be the data type.
oh, okay, right, so,
Yeah.
that doesn't, well, does it have a colon before it?
It does, but string doesn't have one after it.
Right, okay. So we got the password now as a string.
But what's it called when it's in the database?
Oh, this.
Yeah.
Right. Okay, and also we need this as well. Okay. We need all of that.
All right. I think you got it, baby.
I think that's it too, right?
So run that
Okay.
migration. Let's see. Looks good to me. All right, run that server and send a post to it, and let's see what we get back.
Okay. I probably should have already had Postman open, huh? That's this thing? Right. I thought I already did that. Okay. Where is it at? Any particular reason my Postman's not popping up?
It might just be slow as shit. Postman gets slow every year.
Okay.
That could well be it.
It just what the okay, let's try this again. It's actually doing something now.
You ran the installer, I think.
I've already that's
yeah, so close this and then pull that up in Spotlight again.
Okay. Is it no, I don't want to command Q.
Oh, never mind, it's running. That's it.
It looks okay. Cool. Maybe there's an update or something, I'm not sure. is really slow. Okay, so we want to make a post request to localhost 3000 users.
Yep.
Okay, and the body of it. Oh, that's
Let's
something else.
do
uh, so we need such a good movie. Username. Hell, we'll stick with it. Why not? And password. Okay.
And then check your syntax.
Yes, right here. Commas, commas, commas. That should be.
Yeah,
should do
fire
it.
it off.
Very nice.
Well, that looks like a hash password to me. Very nice.
Very nice.
So,
Okay.
very nice. So this is step one of this process. We're going to do this at the beginning of the next two sessions. So this is one, the reason we did this up front, even though it's not all that much new stuff, is we got to be able to shit this out tomorrow. So tomorrow's a big one. We got a lot to do in this one. We got a lot to do in 3. So we want to be fast with this first one. Cool. And as a reminder, we talked about hashing. We talked about how we mix and mash up and do all this stuff to a string. So we turn it into a completely unrecognizable string that can't go back the other way. This isn't encryption. We'll talk about encryption a little bit in one of these lessons. This isn't encryption. Hashing is one way. You cannot get something back once you have it. Encryption, if I send you a secret message, it doesn't do a whole lot of good if you can't read the message. So you need to be able to decrypt that one. So that's encryption. Hashing is one way. Can we mess something up in a hard to rip off, but ultimately very predictable way? That's hashing. All right, last questions before we break.
If you guys wanted, I took some notes on how to do all this. Well, I sent it to you, Katie and Jason. If y'all need it, I can send it to you also.
Cool. Bless you, sir.
Right.
Anything else? All right, have a good lunch, everybody. Cheers.
Thanks, Cal.
Thank
Yep.
you.
Thanks, Kyle. Yeah.